Most people are familiar with the Rubik's Cube, but very few of them have actually solved it. And that's because if you don't know the moves, the Rubik's Cube is one of the most difficult mainstream puzzles ever created.
Frankly, the 3x3x3 is too hard. Okay, it really is.
Now, a lot of that has to do with the fact that there are literally billions of ways to scramble this thing. But what's equally incredible is that with a few weeks of dedicated practice and a little bit of memorization, most people can learn to solve any of those scrambles in a few minutes.
But there are some people who can solve it even faster. A lot faster. They're called speed cubers, and the best of them can whip a Rubik's Cube into shape in well under 10 seconds. As if that weren't impressive enough, the single fastest solve ever recorded in competition is a ludicrous 3.47 seconds.
But could that time go down? Today, we're going to look at why solving a Rubik's Cube in under 3 seconds is almost impossible.
To find out what it takes, I spoke to a world record holder, got a crash course in technique from some local speed cubers.
Now the problem here is you'll notice that things here on the edge don't match.
Problem here is that I don't even see that that's a problem here.
And talked about the mind-boggling math behind the cube with a computer scientist.
There are more positions on the Rubik's Cube than there are grains of sand on all your speeches.
The Rubik's Cube was invented by Hungarian architect Erno Rubik in 1974. It actually started out as an experiment. Rubik wanted to know if it was possible to design a cube made of smaller blocks that could move independently without falling apart. It was only later that he realized he'd also created a puzzle. And that puzzle got very popular. It wasn't long before people were competing to see who could solve it fastest. At the first World Rubik's Cube Championships in 1982, competitors took up to a minute to solve the cube. But speed solvers like world record holder Felix Zemdegs have been chipping away at those times ever since.
I've been to almost 100 competitions all around the world, broken a bunch of world records, and won a bunch of world championships.
One round in competition consists of 5 solve attempts. A computer randomly generates the scrambles to make sure they're difficult enough, and each competitor solves the same 5 scrambles.
You get asked, are you ready? They'll take off the cover, and then you have up to 15 seconds to look at the cube and start the timer. So you get that time to look at it, then you have to place your hands down on the timer, and then solve the cube, and then return your hands to the stack mat timer.
Now is probably a good place to mention that die-hard cubers actually care more about average times than single solves. The fact is, sometimes you just get a lucky scramble. A better test of a speed cuber's skill is to have them solve 5 cubes and average the 3 middle times. Zemdegs currently holds the average solve record of 5.69 seconds. But single solve times still matter. And Zemdegs used to hold that record too, with a time of 4.22 seconds. That was until Chinese speed cuber Yu Shengdu demolished it last fall with a time of 3.47 seconds.
So how unexpected was it for somebody to come along and break your single solve record by 3/4 of a second?
That was pretty unexpected, to be honest. In speed cubing, you don't often see those sorts of insane jumps in time. You can still get a really incredibly quick solve just on one attempt if you have an easy scramble and a bit of luck. And it just so happened that, there's so many people going to so many competitions all the time that something like this was probably bound to happen, but we didn't really expect it that soon.
Okay, so let's put speed cubing aside for a second, because a lot of people, myself included, have never solved a Rubik's Cube at all in any amount of time. And that's because truly solving one, from scratch, without any help from anybody, without watching any online tutorial videos, it's really, really hard. The truth is, if you see somebody solving a Rubik's Cube, they are almost definitely using a memorized sequence of moves to do it.
This is Tyson Mao. He's a co-founder of the World Cube Association, and I asked him to teach me the basics.
I would say there are probably 3 things to think about in terms of what makes someone fast at solving the cube. The first one is the method.
There are many methods for solving a cube, but they all rely on something that cubers call algorithms, memorized sequences of moves that players use to solve the cube section by section. Now, as a rule of thumb, the more algorithms you know, the fewer moves you'll need to solve the cube. A beginner who has committed fewer than 10 algorithms to memory might solve a cube in, say, 120 moves, while an expert who has memorized hundreds of algorithms, can solve the cube in closer to 50 or 60 moves. And as you might expect, fewer moves can translate to faster solves.
The second thing that contributes to how long it takes to solve the cube is how fast you can turn the cube.
The fastest speed cubers in the world average around 10 turns per second over the course of an entire solve, and a lot more than that in short bursts. Take this 16-move finishing sequence, for example.
It looks like this. 1, 2, 3, 4 with this ring finger. Whoa. 5, 6, 7, 8. And now you got to push back with this ring finger. 9, 10, 11, 12, pull. 13, 14, 15, 16, push. The top people can execute those 16 moves in under 1 second.
Are you serious? That's amazing.
The third thing that contributes to how long it takes to solve the cube is how long it takes you to process the information. It doesn't help you if it takes you 5 seconds to figure out what the next step is. Right. Your goal is to try to look ahead and see what the moves for the next step are while you're doing the current one and reducing the pause between those steps.
And then there's the hardware itself. As you can see, there are lots of different types of 3x3 cubes. From the old school version, which was clunky, stiff, and hard to turn, to fancy new models that spin with ease and include tiny magnets to help the faces snap into position.
The actual hardware itself has evolved to the point now where it's really, really good. Like if you give me a cube from 5 years ago, it's probably taking off like a second off my solve time.
If you're going to be a good cuber, back in the day, you had to learn how to prepare a cube and make it good. And so what that would involve is you take the cube apart, if there are imperfections, you might sand some of those things down. You lubricate it with some silicone, let it dry, put it back together, re-sticker, adjust the tension on the screws. It was a big effort. Yeah. Over time, as more manufacturers entered the space, cubes just got a lot better in quality. So the kids these days, they don't know how good they have it. Like the improvement in the cube technology has caused a change in some of these ergonomics. That move that I showed you earlier, there was absolutely no way you could make a turn with this fourth ring finger. Right. The way that people turn the cube and the hand movements that people use evolved as a result of cubes getting better.
Got it. Counterclockwise. So Mao taught me a method for solving the cube that he shows to beginners. Following his instructions, it took me 45 minutes to solve the cube for my very first time. What?
I think if you spent the next 2 weeks on this, you'd probably get your time down to about 90 seconds.
90 seconds, okay. I'm gonna try to get to a point where I can solve the cube consistently using the method Tyson has given me today in under 90 seconds. And we'll see if that actually happens.
So I took my new cube and got to practicing. In the first few days, I went from needing around 20 minutes to solve the cube to just under 3. Not bad for a newbie, but that's still an eternity for someone like Tiffany Chien, a local speed cuber who averages just under 10 seconds per solve. She's so good, she can solve a cube blindfolded and one-handed.
You just solved a Rubik's Cube with one hand more than 3 times faster than I can solve it with 2. When you pick up a cube, you don't look the way I look when I pick up a cube, which is like, it's manic. You are actually not going full tilt.
Oh, yes, definitely. Yeah. My hands can definitely move faster than my brain can during the solve. So it's limited not by how fast my hands can move, than what my brain can see, what my eyes can see.
So are you exercising that kind of restraint throughout the entirety of the solve?
So my strategy in competition is definitely to solve it as smoothly as possible, with no pauses. Because I find that if I try to turn quickly when I'm nervous, I'll turn very poorly.
I had her critique my solving method.
This is so intimidating. I'm gonna mess up real bad. Okay. Ready? Okay. Oh no.
That's the last step.
Damn, that was a slow one. 1 minute, 41 seconds. I'm ashamed. Okay, so do you have any tips based on that?
For starters, she said I should try opening with a more efficient move.
The second tip is more general for the entire solve. I noticed that you spend a lot of time turning the whole cube around, or using your whole hand to turn the cube around. So while you're doing the second layer, you see the piece over here, so you go like this or something. But you can see pieces that are on the other side of the cube. So you shouldn't need to do so many rotations of the whole cube.
So given what we've learned about speed cubing, what is the lower limit? How fast can we go? To figure that out, it helps to understand some of the math behind the cube. And for that, we turn to computer scientist Tom Rikicki.
There's 43 billion positions, which is 43 quintillion, right? So it's really a big number.
Rikicki has been fascinated with the cube ever since he was a kid. And around the turn of the millennium, he started puzzling over one of the great unanswered questions of the cube. Now, this is a little confusing at first, but stick with me. Of those 43 quintillion configurations, there are some of them, like this, that are very easy to solve. If I handed you the cube in this state, you would know that it takes just one move to resolve it. But most of the scrambles on the cube are a lot more complicated than that. So the question Rikicki wanted to answer was this: what is the maximum number of moves that would ever be required to solve the cube, no matter how scrambled it is? Mathematicians call that figure God's number, and it went unknown for more than 30 years until Rikicki and his colleagues figured it out.
We used a really fast program with all sorts of clever tricks that let us solve about 1 billion positions a second.
Wow.
And then we used 1 billion seconds of computer time. Now, 1 billion seconds of computer time sounds like a long time, and really it is. Except for if you've got thousands of computers, it's a lot less.
So what is God's number when it comes to the Rubik's Cube? 20. No matter how complicated this scramble gets, you are never more than 20 moves away from being completely solved. And it's usually less than that.
Almost all positions require fewer than 20 moves. 18 is the most common. So your typical scramble you're going to get from your timer is going to take 18 moves to solve optimally.
Now, you'll remember that the fastest speed cubers on Earth average about 10 turns of the cube per second. If you divide God's number, which remember is never more than 20, by 10 turns per second, and you get solve times of under 2 seconds. And look, here's proof that it is physically possible to solve one in that time. In fact, this robot can solve it in under 1 second. So from a purely mathematical standpoint, a sub 2 second solve by a human should be possible. There's just two problems with that line of thinking. First of all, just because a computer can quickly identify the fewest number of moves to solve a cube doesn't mean a human can match it.
There's nobody out there that can look at this cube and say, I'm 18 moves from solved, and this one takes me to 17. That's just not something which humans can do.
And second, even if a human could look at a cube and quickly identify the fewest number of moves required to solve it, there's no telling whether performing that sequence of moves would be any faster than their usual technique.
That's because there can be a trade-off between the number of moves it takes to solve a cube and the speed at which you can execute those moves.
Ultimately, solving the cube requires executing physical moves, and the faster that you can execute those moves, the less time it takes to solve the cube.
But it's not as simple as minimizing the number of moves.
It is not. Ergonomics and other things come into play. So one example is, this state, which you notice that there are 3 stickers here that are not solved. We call this case the U permutation. And originally when people were solving this, there was a 9-move sequence that looked like this, and this is how people solved the cube. But then over time, I want to say around 2004, 2005, an 11-move sequence became more popular because it was just faster to execute. You want to minimize the number of moves, but you also want to be able to make those moves quickly.
So what do speed cubers think the limits actually are?
People have asked me to speculate what the world record will eventually reach, and every time I've speculated, I've been wrong. So I'll take another shot at it again. I think low 5s is probably, at least from an average, maybe 5 flat.
As for the limits of a single solve,
In the next 5 years, I would expect probably something under 3 seconds, given just enough chances. My best ever single solve at home in practice is like 3:01, but then there's a couple of people who've done like under 3 at home. Again, just pretty much depends on luck. Like probably I could do a 2.5, but it's just when will it happen?
faster times will come down to a combination of luck, improvements in hardware, the development of more efficient methods, and smoother execution. As for me, for 2 weeks, I brought a Rubik's Cube with me everywhere I went and practiced at least 20 minutes a day. I got my single solve time down to 59 seconds and my best 5-solution average down to 1 minute, 8 seconds.
So I actually made a ton of progress, and you probably could too. And while I'm never going to compete with any of the world's fastest speed solvers, that's totally fine.
Because what they're doing is already almost impossible.